In this video, we're going to talk about building quadratic models, and we're going to do that through looking at 4 word problems, and I'm also going to show you how to use your graphing calculator to find quadratic regression. Our first problem deals with economics, where revenue, capital R, is defined as this equation here. So it equals X times P, where X is the units sold of something, and P is its selling price. So let's say Texas Instruments sells a certain calculator, so a number of them, X, at this equation. So the number of calculators that they sell is equal to this, where remember P is its selling price. So let's write an equation for R, so this guy, in terms of P. So I take this first equation and this equation, and I plug in X into here, and I get this quadratic for the revenue in terms of P. Next, let's graph that equation and find the domain of R. Now you'll notice that my x-axis is actually P and my y-axis is actually R. So we're really looking for the practical price that we can sell to gain any amount of revenue. So although this quadratic will go on to negative infinity and positive infinity in both ways, it really isn't practical when we talk about money and items sold. So it's going to go from 0 on the x to 140 on the x. So it's going to be written like this. So x as an element goes from 0 to 140. It doesn't include 0 because I'm not going to sell something for 0 as a price, but I can sell it for 140, so that's why it includes it. Now let's find the maximum revenue R. So there's 2 ways that you could do this. You could use the maximum function on your calculator after you've graphed this equation here, which would give you the R value, which is your Y, for whatever P or X value is the highest. Now there's also an algebraic way to do this. So there's something called a vertex. So that means that that's either the high point or the maximum, or the low point or the minimum of a quadratic. So we're dealing with a maximum here because it's a negative, it frowns. So that vertex will give us the maximum point, which means it will give us the maximum revenue. And the equation for that is x, so that's going to be a point here, equals negative b over 2a. So that b and that a come from the quadratic a, b, c coefficients that go in front of the x squared, the x, and the constant. So if I plug in my values for b and a, I end up with $70. So that means that at $70 per calculator, I'm going to get the max revenue. So I haven't found the max revenue yet, but that's going to be the y value that pertains to this x or p value. So I plug in this p value into my equation and I get the maximum revenue of $735,000. All right, and from there we can actually find how many calculators are sold at that price. And all we need is that original equation of x in terms of p, plug in 70, get 10,500 calculators. All right, last thing about money, I promise. So what price should be charged to collect at least $675,000 in revenue? So you probably guessed that we would plug this number into the equation for R and solve it out, and luckily I can divide the whole thing by 150 and I can factor, which is really nice, and I get 2 answers. I get positive 50 and positive 90, which means that between 50 bucks and 90 bucks is what I should charge to get at least this much in revenue. You could also graph a line like y equals $675,000 on top of your quadratic and find the 2 intersecting points on your calculator if you wish to, and you would also get 50 bucks and 90 bucks. So our next problem takes a little bit of a geometric turn. Let's say that I have a plot of land that is surrounded by a fence, and it's a rectangular plot of land, and the sides are represented by x and w. And the perimeter of the whole thing, if I add it all up, equals 2,000. So let's find the equation for the area of this rectangle in terms of x. So all I do here is isolate w to get w equals 1,000 minus x. I plug in the w into area equals x times w, and I have my result here as a quadratic as area equals 1,000x minus x squared. So now let's find the maximum area of this rectangle. So you can solve this with your calculator. but for the sake of time, I'm just going to show you it algebraically. So to call back the idea of this vertex, so this maximum or minimum point, because I'm looking for maximum, I'm going to find the turning point or the vertex or the maximum of the equation that we just came up with. So I plug in my negative b and my 2a and I get 500 for the x value. But remember, I'm looking for maximum area. So I have to plug 500 back into the equation we just found, and I find that the maximum area of this rectangle is 250,000 square units. All right, moving on to our third example. Let's say a projectile is fired from a cliff that's 500 feet above water. The height of the projectile is modeled by the equation this thing. So y is our height, and x is going to be our distance that it goes from the cliff. Now let's find the max height of the missile. So again, you could do this graphically, which I've done here, and I found that my x value is 2,500. But remember, this is height, so I plug it back into the equation and find the height to be 1,700 feet. But if I wanted to do that algebraically, I would use this vertex thing again, noticing a pattern, and I find the x value to be this after I plug this whole thing in, and then I plug the x value in here and here to get my y, which gives me the maximum height. So let's figure out the distance that the projectile will be from the cliff once it strikes the water. So there's two ways to do it. Again, you can graph it and you can figure out where it will intersect with our x-axis or y equals 0, and it will intersect at 2 points. Or I can set the equation equal to 0, and unfortunately, because these numbers are not so pretty, I have to use the quadratic formula, which will give me these same numbers, about negative 458 and positive 5,458. But the important thing here is that I can only use one of these, and that's because we're talking about distance. So when I launch something off a cliff, it can go about 5,000 feet. But it's not going to go behind me at the same time and go to negative 458 feet. So I have to reject this answer here, and this guy's our answer. Our fourth word problem brings us to San Francisco, to the Golden Gate Bridge. Now, you may have thought to yourself when you first saw this thing, wow, that looks like a model of a quadratic function right there in the middle of the bridge. Or not. So let's put some information on this thing. So what I've modeled here is I've made these two red lines, the x-axis and the y-axis, that intersect at the origin, and I've made this point up here 2,100 feet this way, and this point is 2,100 feet this way on the x, and they're both at a height of 526 on the y. And let's model that quadratic curve here as y equals a times x squared. So our first job is to find the value of a. So I pick this point here, and I plug its information into that equation, so x and y, and I get a to be this fraction. I'm going to leave it that way. So plugging a into here, this is the equation of that curve. So from here, let's find the height of the cable, or the y value, when we're 1,000 feet from the center of the bridge. So all that means is that x is 1,000. I plug it in here into the equation that we just found, and that gives me about 119 feet as the height, 1,000 feet out from the center of the bridge. And last but not least, as promised, a video within a video of how to find quadratic regression on your calculator. The first thing I have to do in order to find the curve of best fit is to enter in my data points. So remember, I go to Stat, and then number 1, which is Edit, and I'm going to enter my list of data. So I already have this inputted here, pretty quick and easy to do. So in order to figure out what kind of curve I'm going to need, remember we go up to second y equals, which is the stat plot. So it's going to create a scatter plot, and I need to turn that on. So I hit enter, and I page over turn that on. And then remember, in order for it to show as a scatter plot or a stat plot, we have to go to Zoom, and we click number 9, which is Zoom Stat. And here we have a quadratic looking function. So that means I'm going to use quadreg, or quadratic regression. So I hit Stat, I page over to the calc list and I find quadratic, which is number 5. So in my calculator, it already pushes L1 and L2 into the x and y, and then I'm actually going to store my regression equation. So I'm going to page down there, and how I find it on this calculator is I hit vars, page over to yvars, function, and I'm going to select y1 because I know it's empty in my calculator here. I page down, I hit calculate, and here are my A, B, and C values for that quadratic. So it's a good thing I stored it because writing that down by hand is a bit of a pain. So if I actually go to the graph, it should actually have that graph there as well. And something else that you can do is you can use the table of values, which I'll show you in a minute once this finishes graphing. And from there you can actually find the exact value of this quadratic regression of whatever x value you are looking for. Right? So you can use that guy. Alright, that's going to do it for this video. Thank you for watching.